Good morning. This is Dr. Janet, Assistant Professor, Department of Management Studies, BBA, Women's Christian College, Chennai. In this session, I would like to deal about Simplex Method in operations research. Simplex Method is a technique to solve the linear programming problem to come out with the optimal solution. It's an iterative process where we follow a step-by-step method in order to come out with the feasible solution. So in this session, let me solve a problem in Simplex Method for a better understanding. Let me share my screen. In Simplex Method, we have the objective function is denoted by the maximization function of z, max z equal to (21x1) plus 15x2, subject to the constraints minus x1 minus 2x2 greater than or equal to minus 6. The next constraint equation is 4x1 plus 3x2 greater than or equal to 12. So the first constraint equation is denoted by a negative sign, it is minus x1 minus 2x2 greater than or equal to minus 6. So the minus sign can be converted into a positive sign by multiplying with minus throughout the equation. So equation 1 becomes x1 plus 2x2 greater than or equal to 6. The first step in Simplex Method is that in the constraint equation, we have the inequality function is greater than or equal to. This inequality function has to be converted to equality function by introducing a slack variable. x1 plus 2x2 plus s1 equal to 6. The next equation becomes 4x1 plus 3x2 plus s2 equal to 12. So in these two equations, you can see that the inequality constraint is converted to equality constraint by introducing a slack variable s1 and s2. Similarly, in the objective function, that is in the maximization function, the slack variable has to be introduced and it becomes 21x1 plus 15x2 plus, when we introduce the slack variable in the objective function, we have to introduce it with a coefficient 0. So this is 0 s1 plus 0 s2. The second step is that we want to construct a table and we want to enter the values in the table with the help of this equation, that is the constraint equation and the objective function. If we construct a table, first column is the quantity, followed by correct variable, contribution, and in the constraint equation we have x1, x2, s1 and s2, and the last column will be the ratio. Now about the contribution, we want to introduce Cj. We start by entering the values from quantity. So if you look into the previous slide, you can see the equation, the constraint equation, x1 plus 2x2 plus s1 is equal to 6. The value which is at the right hand side is equal to is considered to be the quantity. This becomes 6. And then in equation 1, we have introduced the slack variable s1. S1 to be entered here. and its corresponding coefficient in objective function is 0. And while we consider the equation 1, the coefficients of x1, x2, s1 and s2 have to be entered in this table. So the coefficients are 1, 2, 2, and s1 it is 1. And in equation, the first constraint equation, we don't have s2, so we enter 0. Now we'll move on to the second constraint equation, the quantity that is the right hand side of the equal to sign, we have the value 12. So 12 has to be entered here. And the current variable is S2 and its corresponding coefficient is 0 in maximization function. And then the coefficients of x1, x2, s1 and s2 have to be entered. The coefficients are 4, 3. We do not have s1 here. So in the place of s1, we'll enter 0 and s2 it is 1. 4, 3. Since we don't have s1, here, and then 1. Now we enter the values of Cj here. That is the coefficients of x1, x2, s1 and s2 from the maximization function. The coefficients are 21, 15, 0, 0 again. Now let us introduce Zj. We obtain Zj by multiplying x1 with the contribution. So we multiply 1 with 0, 2 with 0, 1 with 0, and again 0 with 0. The values are 1 into 0 is 0, 2 into 0 is 0, 1 into 0 is 0, 0 into 0 is again 0. The next step in simplex function is that we want to find out Zj minus Cj. Zj minus Cj. We have the value for Zj here and Cj here. Now we have to find out the difference. 0 minus 21 is minus 21. 0 minus 15 is minus 15. 0 minus 0 is 0. And 0 minus 0 is again 0. Now, in Zj minus Cj, we want to find out the most negative value. So we can see that minus 21 is the most negative value. So we are going to choose this column. This column is selected. Once we choose this column, the next step is that we want to find out the value of R, that is the ratio. So the value of R is determined by quantity divided by the corresponding x1 values. Since we have selected this particular column, we are going to choose the values of x1. That is 6 divided by 1, 6. 12 divided by 4 is 3. And the next step, by analyzing the ratio values, we have to choose the least positive value. So out of 6 and 3, 3 is the least positive value. So we are going to choose this particular row. After choosing this, we can see the row and the column, the selected row and the selected column intersect at a particular value. So in this problem, in this table, you can see 4 is the intersected value. So this value we call it as the pivot value. Now, if we look into this table, in Zj minus Cj, we have negative values minus 21 and minus 15. The condition in simplex method is that we can have only positive values or 0. Since we have negative values here, we want to construct one more table, that is the iterative process. We follow another process in order to rectify the negative value and to come out with the positive value to arrive the feasible solution. So while we move on to the second table, we want to consider that since this is 4 is a pivot value, While you move on to the second table, the 4 have to be converted to 1 and the other value, that is 1, to be converted to 0. This is the general procedure that we follow in simplex method. So we move on to the next slide to construct the second table. Quantity, current variable, contribution, x1, x2, s1, s2, and ratio r. Use CJ here. It's 21, 15, 0, and 0. We'll have a look at the previous table. As I said already, this is the pivot value 4. While we move on to the second table, the value of 4 has to be converted to 1. So we can convert 4 to 1 by dividing the value of 4 by 4. So 4 divided by 4 is 1. So we have entered 1 here. Since we divide 4 by 4, the remaining values in this table should also be divided by 4. I repeat, the other values along the same row in the table have to be converted, have to be divided by 4. So here we have converted 4 to 1. And the next value will be 3 by 4. And then 0 by 4 is 0. And at last 1 divided by 4 is 1 by 4. Now we want to enter the values of quantity and current variable contribution. So in this particular row, you can see that the value of ratio, the least value, positive value is 3. And the ratio value, while we move on to the second table, it has to be entered and it is considered as a quantity in table 2. So the value of quantity is 3. And now, since we have selected this particular column, the corresponding current variable in contribution will be x1 at 21. So we have arrived with a new set of values in table 2 with the help of table 1. Now, the other values in row 1 should also be converted. So the value of 1 have to be converted to 0. So for our understanding, let us have this row, we name this row as R1. And the table 2, the new set of values, and this particular row, we'll have it as R2. So we are going to make the adjustments between R1 and R2 to come out to derive the new set of values in this particular row. So I write it here separately. Adjustments have to be made between R1 and R2 so that the place of x1 we get 0 and the new values for the x2, s1 and s2. So x1 here 1 have to be converted to 0. The existing value is 1. And here in R2 the existing value for x1 is 1. So the adjustments have to be made between these two values in order to get 0. So we know that 1 minus 1 is 0. So we are going to follow this expression R1 minus R2. So R1 minus R2, it is 1 minus 1 for corresponding x1, it is 0. So this expression R1 minus R2, we are going to apply for the remaining values also. We move on to x2. So in table 1, the value of x2 in row 1 is 2. Here the value of x2 is 3 by 4. So it is 2 minus 3 by 4. So 8 minus 3 by 4. It's 5 by 4. And then for S1, the value, the corresponding value for R1 it is 1. And for R2, the corresponding S1 value is 0. So follow the expression of R1 minus R2. So 1 minus 0, it is 1. For S2, the corresponding R1 value is 0. And the corresponding R2 value is 1 by 4. So 0 minus 1 by 4, it is minus 1 by 4. And again, we want to find out the value of Q, CV, and C. So for quantity, again, we follow the same expression of R1 minus R2. So for R1, the Q value is 6. 6 minus, and here R2, the Q value is 3. 6 minus 3, it is 3. Current variable, it is S1, and C, it is 0. S1 and 0. Now we want to find out ZJ. So ZJ we obtain by multiplying with the values of X1 with the contribution. So 21 into 1, it is 21. And then 3 by 4 into 21, 63 by 4. And then 0 into 21, it is 0. At last 21 into 1 by 4. It's 21 by 4. The last step is Zj minus Cj. So we have got the values of Zj here and Cj. We want to find out the difference. So Zj is 21 and Cj is 21. 21 minus 21 is 0. And then Zj is 3 by 4 and Cj is 15. So 63 by 4 minus 15. So it is 3 by 4. 3 by 4. And then 0 minus 0, it is 0. 21 by 4 minus 0, it is 21 by 4. So when we look into Zj minus Cj, you can see that we have only positive values and a 0 here. We don't have a negative value. So that we can stop with this table 2 and then we can calculate the optimal solution. We move on to the next slide. So the optimal solution is calculated as follows. Maximization Z equal to 21 x1 plus 15 x2. Now we want to enter the values of x1 and x2. Let me move on to the previous table. So if we look here for x1, the corresponding quantity is 3. So we are going to substitute 3 in place of x1. And again, in this table, we do not have the value for, we do not have x2 here. So in the place of x2, we are going to substitute 0. 21 into 3 plus 15 into 0. This is 21 into 3, 63. 0 equal to 60. So this is the optimal solution. So the optimal solution is reached at the point x1 equal to 3 and x2 equal to 0. So that will be the conclusion. Optimal solution is x1 equal to 3 and x2 equal to 0. Therefore, maximization of z equal to 60. Thank you.